Hello, my name is Heyman Franklin and my metric number is A180116. Together we are Group 2 and we are going to talk about the trickling filter.
Hello, my name is Azra Nurbadrina and my matrix number is A180855, and today I will be presenting about the history of trickling filter and the advantages of a trickling filter.
Hi, I'm Jenny with matrix number A179629. I will be presenting about the introduction and also the design of the trickling filter.
Hi, my name is Aina Farhana binti Amran with metric number A183841. I will be presenting the mechanism of secondary treatment method. I hope you guys enjoy this video.
Trickling filter is an aerobic wastewater treatment. It is the one of secondary sewage treatment which is categorized under fixed film biological treatment. In trickling filter, the organic matter from wastewater is removed biologically by using the bacteria or microorganisms which are attached to a medium, or we call it as filter media.
Hello, I'm Azra and today I will be presenting about the history of trickling filter. Dayton was the one who introduced trickling filters and has been involved in the biological wastewater treatment industry for over a century. Trickling filters have proven to efficiently remove pollutants from wastewater since they were invented, earning its name as a technology that will continue to serve the industry well into the future. Until now, trickling filters are still considered a treatment alternative due to their low energy and maintenance requirements and their ability to treat variable organic loads and toxic substances. They were first introduced in the US in 1901 at Madison, Wisconsin. By 1910, several additions in Midwest and Eastern cities brought the total to 10.
Typically, trickling filter consists of 6 main components, which are distribution system, biofilm carrier or filter media, containment structure, under drain system and ventilation, trickling filter pump station, and secondary settling tank. Let us discuss further about the 6 components of the trickling filter. The first component is distribution system. It is the path traversed by wastewater or primary effluent, or in another word, influent, to enter the bioreactor. The commonly used distribution system is rotary distributor. The rotary distribution system typically includes rotating influent distributor and contacting influent distributor arm. The rotating influent distributor may be hydraulically or electrically driven. Secondly, biofilm carrier, or in the other word, filter media, is a permeable medium which wastewater is distributed to trickle through. An ideal filter media is the filter media with low cost, durable, and provide high specific surface area. The filter media of trickling filter is typically made up of rock and slag bed with up to 60.96 meter in diameter and 0.9 until 2.4 meter deep. The rock size varying from 2.5 until 10.2 centimeter. The types of biofilm carrier or filter media that are commonly used are rock, slag, random plastic, and plastic. Thirdly, containment structure is vital for supporting the filter media by avoiding wastewater flushing and wind protection. For non-self-supporting filter media such as rock and random plastic, precast or formed concrete tank will be used as containment structure. For self-supporting filter media such as plastic modules, the wood, fiberglass, and coated steel will be used as containment structure. The next component is on the drain system and ventilation. This system aims to collect treated wastewater for conveyance to a downstream unit processes and create a plenum that allows for the transport of air throughout the trickling filter media. The components included in this system are under drain channel, outlet box, effluent channel or outlet pipe, and vitrified clay under drain block. Vitrified clay under drain block is used to support media on the concrete floor of containment structure. The fifth component is trickling filter pump station. This pump station responsible for pumping primary effluent or influent into distribution system and recirculating trickling filter underflow to achieve hydraulic load and reduce BOD loading. Lastly, secondary settling tank, or in the other word known as secondary clarifier. In this component, the waste sludge will be removed from wastewater. The effluent is sent to two directions. The first direction is the recirculation through trickling filter to reduce BOD loading. The second direction is for disinfection and aeration before the treated water being released to stream or river.
Hi, my name is Aina and I will be representing the mechanisms of the secondary treatment method. First of all, you need to know that the secondary wastewater treatment processes use microorganisms to biologically remove contaminants from wastewater. So, trickling filters are biologically reactors within wastewater treatment. The main function of trickling filter is to remove organic matter and ammonia from wastewater. How do trickling filters work? Compared to the activated sludge process, the microorganisms are not suspended in the mixed liquor but are attached to a fixed bed surface. Nowadays, the fixed bed surface is usually provided by structured plastic film media. The wastewater from the primary clarifier is continuously trickled over the first layer of plastic film media using a rotary distributor, while wastewater travels down to the bottom of a trickling filter across corrugated patterns within the plastic film media to ensure good water-air mixing. Let's move on to the operation of how the trickling filter works. The trickling filter process goes through a series of operations which involve the following stages. The primary effluent enters the trickling filter through the feed pipe. Firstly, the raw or primary sewage from the primary clarifier tank enters the trickling filter tank at a steady rate. A series of operations like screening, grit removal, and primary clarifier must be done to prevent the trickling filter system clogging. Next, it will flow upward to the arms of the perforated rotary distributor. The filter bed is packed with constituents like rock, gravel, redwood, synthetic material, and etc. that acts as media for the attachment of the microorganisms. Moving on to the next steps, the filter media is chiefly composed of porous media that will increase the surface area for the decomposition of the organic matter by the organism. So the effluent passes through the filter media containing microbes. So the organic matter is oxidized by the aerobic microbes. Oxygen is drawn into the filter media via vacuum or chimney effect. The biofilm layer uses the dissolved oxygen trapped within the filter media and oxidize the organic compounds by releasing carbon dioxide gas, water, and other oxidizers and products. Next, the filter effluent goes down the drainage system to the clarifier. The clarifier separates small colloids out of effluent as waste sludge. The treated wastewater from the trickling filter bed goes down the drainage system and further undergoes tertiary treatment via membrane filter and disinfection before secondary sedimentation. A secondary clarifier is a sedimentation unit which separates the small colloids, suspended particles, etc. at the bottom of waste fluid. So the waste sludge is recycled back to the trickling filter. And lastly, the effluent is treated further by using disinfectants. In conclusion, we can see that the trickling filter is one of attached growth systems. The attached growth system is the microorganisms responsible for the degradation of the organic matter attached to the non-submerged baking material. Now, let's look at the trickling filter aeration. Firstly, we need to know that the trickling filters are operating under aerobic conditions, but mostly without the use of forced ventilation or aeration. Second, the tower shape of trickling filters causes air to be sucked inside the tower over the slots at the trickling filter bottom. This effect is called as chimney effect. And lastly, it results from air buoyancy which occurs due to a difference in indoor to outdoor air density. Last but not least, depending upon the hydraulic and organic shock load, trickling filters can be categorized into two types, namely high rate and low rate trickling filters. The hydraulic loading rate can be defined as the sewage flow, stands for Q, per unit volume, stands for V, of the filter bed in day, while the organic loading rate can be defined as the kilograms of BOD, Y5, introduced into the per unit volume, stands for V, in a day. Recirculation of the effluent is not provided in the low-rate filters. In contrast, high-rate filters are provided with a written pump between the trickling filter tank and secondary clarifier that aids in the effluent recirculation.
These are the advantages of trickling filter. Trickling filters are simple and reliable. With fewer moving parts than activated sludge systems or other options, they need less maintenance. Trickling filters are also known to have greater resistance to shock loadings due to the nature of attached growth. Additionally, since trickling filters typically only require power for pumping, they use much less energy than other aerobic treatment processes. Since trickling filters are pretty much easy to build on itself, the price is inexpensive and low cost. It's affordable to be repaired and maintained compared to other wastewater treatments. Trickling filters have a simple design. They're super easy to operate since its build is very straightforward from a mechanical standpoint. Trickling filters are effective and they're excellent at removing organic material, especially for rapid reduction of BOD, biochemical oxygen demand levels in streams. When properly designed, a biological trickling filter can produce effluent of high enough quality for compliant discharge. It also has a relatively small footprint, meaning the use of the newer technology of lightweight and high compressive strength structured plastic biomedia made it possible from a big-sized trickling filter to go up to 6 to 14 meters and reducing the footprint area. It could be placed in smaller communities in hopes of increasing the efficiency in removing organic materials.
Hi, I'm back. Now, it's time to know some of the disadvantages of the trickling filter. Unpleasant odor is one of the undeniable risks from trickling filters. One of the potential causes of this problem is the process of anaerobic decomposition in filter media due to excessive organic load. Some of the remedies for the cause include enhancing aerobic conditions in treatment units via chlorination before the primary settling treatment of wastewater, recirculating effluent obtained from filters to maintain aerobic conditions, and pre-aeration of wastewater. Inadequate ventilation is another potential cause of unpleasant odor. Some of the remedies for this problem include increasing hydraulic loading to wash out excess biological growth, installing fans to induce draft through filters, and removing debris from filter effluent channels, under drains, and top of filter media. Ponding on filter media is another disadvantage when it comes to the trickling filter. Ponding is when water can be seen standing on top of the trickling filters. The potential cause of this problem is excessive biological growth such as fungus or accumulation of foreign matter such as sediments in or on the filter media. Some of the remedies for this problem include reducing organic loading into the filter media at designated times and using high pressure stream of water to flush filter surface, simultaneously loosening medium aggregates with steel bars. Trickling filters also cannot escape the nuisance of filter flies. Filter flies or Cicoda feeds on organic matter which eventually disrupts the functioning of bacteria in the filter media. One of the potential causes of this nuisance is inadequate moisture in filter media. The remedies for this problem include increasing hydraulic loading into the filter media and flooding the filter for several hours each week during fly season. Another potential cause of this nuisance is poor housekeeping around the areas and systems of the trickling filters. The remedies for this problem include mowing the area around the filters and removing weeds and shrubs that has grown inside and around the filters. Ever since its humble beginning, the trickling filter technology has served mankind by providing them with a continuous supply of water with better quality. We may call it an old-fashioned technology, but with tremendous improvement throughout the years, the trickling filter technology has proven to be on par with other technologies in the secondary wastewater treatment system. With that being said, let us continue to learn and innovate this technology for a better environment. This is Group 2, and from all of us, thank you for watching. Be curious and keep on learning.